let's start to talk about the code for the MPU9250. This code is extremely similar to what we've done with the BMP180 with some few minor adjustments. The very first thing we want to do is include the wire.h library, which I've done here, and we want to define the address of our MPU9250. So these words here again have been saved as 0x68. Again, you can determine this address by either going on the datasheet, or you can run the I2C scanner and easily find that as well. Now, I have two different types of variables here. I have a float and a long. Now, what this long is doing is allowing me to read the raw values from the registers that are appropriate, the accelerometer and gyroscope values. And what this float is doing is it's converting those raw values into meaningful numbers for us. And float also gives us decimal places, which has a higher level of accuracy. So let's jump right into our void setup here. So what we're doing is we're beginning communications at 9600 baud, and we are beginning our transmission to our MPU9250. So this MPU9250 address has been saved as 0x68. So either you can write MPU9250 underscore address, or you can write 0x68. Now what we're doing, we'll be setting this power management as per what the datasheet requires us to. So we'll be setting this to, we're going to write to this at 6B, and we'll reset it with wire.write to 0. So above what's happening in this section is our MPU9250 has initialized. So now we can move on to accessing the various sensors that are built into the MPU9250. That's what these other two sections will be doing. So here we are going to be waking up our gyroscope. So again, we'll begin transmissions with our MPU9250. Then we will write to 1B. So this is actually the gyroscope's power settings. So we can see what that is in our register map here. So it's important to note we have two different types of data sheets for this sensor. We have a register map and we have a normal data sheet, product specification guide. I highly recommend you guys will go through this because it's extremely important to understand this data sheet. It can be a bit confusing with the sensor. So let's actually find where our 1B and 1C are. So you can see 1B is our gyro config and our 1C is our accelerometers config. So let's go back to our code. So here what we're doing is we're setting the sensitivity of our gyroscope. So let's go back to our register map. I can show you. So you can see our gyro FS select, and also for our accelerometer FS select, the pertinent bits for that is bit 4 and 3. So if we go down to page 14, we can see the different scale settings we can have for this sensor. So for our gyroscope, we can either have 0, 0, 0, 1, 1, 0, and 1, 1. So we can have 250 degrees per second all the way up to 2000 degrees per second, our reading rate. And we have to change bits 4 and 3. Now the same goes for the accelerometer. We have either 0, 0, 0, 1, 10, and 1, 1. So we can either get plus or minus 2 gravity, plus or minus 4, 8, and 16 G. So these are different resolution rates for the accelerometer and gyroscope. Let's go back to our code here. So as you can see, I've set this in binary. So bits 3 and 4 are 1 and 1. The rest are all 0. As per this register map here, you can see we would like to keep all of these other ones 0 as we reset them, but only this one is allowing us to select a resolution rate. Now we'll end the transmission and let's move on to our accelerometer. So here is we'll be waking up our accelerometer and initializing it. So we are beginning our transmission with the MPU9250. We're writing to 1C. Again, 1C, we saw this just now, is the power settings adjustment for the accelerometer. And again, I've set this to the highest sensitivity and I've ended that transmission. Let's look at our void loop. Our void loop again is extremely similar to what I've done with the BMP180. These are just the AX, AY, AZ values are going to be printing out, and the GX, GY, GZ values. So I have two functions here again that I'm drawing back into my void loop, the get gyroscope values and get accelerometer values. Let's figure out what these are doing. So here is my get accelerometer function. So first, we are beginning transmission with the MPU9250, and we will be starting our readings for the accelerometer. The starting register for this is actually 3B. Now let's take a look at this in our datasheet. So 3B is down here. So you can see these are all of the registers that contain the pertinent values for the gyroscope and accelerometer. You can see that there's a high byte and a low byte. So the high byte will be read first and the low byte will be read later. But it's important to note that both of these, 3B and 3C, are actually combined to get the X reading for the accelerometer. And for the Y reading, we need 3D and 3E. The same goes for the 3F and 4D. These are all for the accelerometer. So let's go back to our code here. So what's happening is the starting register is 3B for our accelerometer readings. We end the transmission, and here we are requesting from the MPU9250, which is our address here, the 6 registers that come after 3B. So here raw AX will be shifting over 2 bytes. So 2 bytes are stored here, so it's actually getting 3B and 3C. The same is with AY and the same is with AZ. So it's getting the next 2 registers and saving that. So these are the raw values. So now we actually want to convert these into something meaningful. We can get these by using that real AX variable I created. So raw AX, since I'm using the highest resolution mode, I have to divide the raw AX with 2048. Now where can this number be found? This conversion factor can be found in our datasheet here on page 9 of it. So you can see for the AFS selection 3, which is the highest sensitivity scale, you have to have 2048. You'll divide that. So let's go back here. So I've divided the appropriate number and I'm outputting actual meaningful values, our real AX, AY, and AZ. And the code for the get gyroscope values, this function is extremely similar to the one above. We're just beginning transmission with our MPU9250. We are writing to this register 43, which we saw earlier. After all of those, we want the 6 ones that come after that, which will be including our raw GX, raw GY, raw GZ. These are just shifting over, and these ones will save that value. So we'll take our raw GX here and set that equal to real GX and divide that with 16.4, which we can find here. 16.4, so our highest selection factor here, 16.4, that's what they want us to divide with. So we can go back to the code, we're just dividing with these values, and now we're drawing up these 2 functions directly into our void loop. So the great thing about making all of our accelerometer and gyroscope values as different functions is we can draw them right back into our void loop and output values easily. Now you'll see when we combine both of these codes together how this plays a large part. So let's download this code into our Arduino. And let's look at our serial monitor. Now you can see we have our accelerometer values here and our gyroscope values here. When I move this circuit, you can see how the values are all changing. So our code works, it's giving us appropriate values. And if you want more or less readings, what you can do, you can change this delay here. It's at 10 milliseconds right now. You can increase it or decrease it if you want more or less readings. But that ends the coding explanation for our MPU9250. Let's move on to actually combining both the MPU9250 and BMP180's code together. So in the previous sections, we've seen how to code the BMP180 and MPU9250 individually. But let's see how we can combine them. So combining the 2 codes is actually extremely easy. All you have to do is copy and paste them in the correct format. So what I've done here is I've included the wire.h library, and I've defined the BMP180's address and the MPU9250's address, and I've discussed this previously in the other clips. Here, the float and long, these variables are has been directly copied from the MPU9250's code, and all of these variables have been directly copied from the BMP180's code. Let's move on to our void setup function. So here we begin communication with our I2C device using wire.begin, and we start displaying stuff on our serial monitor at 9600 baud. Now below, this is our added function for our MPU9250. So here again, what this one does is it's just initializing our MPU and it's waking it up. The second section is accessing the gyroscope, and this third one is accessing the accelerometer. Now in our loop, the only thing I've done here is edit it slightly so that all of the data values can show up on the screen. And the only difference is that I've added my functions where I'm getting all the variable values from, all the stuff from the registers, interpreting them, and I'm displaying them onto the screen. That's why you should always create functions like this so that you can throw them right into your serial monitor, and it makes it very easy to deal with. So now here I've just copied in directly from our BMP180 the read to register function, which I've explained earlier, and we have our group addresses, and we have a read uncompensated temperature function and our read uncompensated pressure function. We have our calculations for them, and below we have our functions we've created for the MPU9250. So our get accelerometer values, this is again just been directly copied in, this one, and our get gyroscope values, this has also been directly copied in. That's really it for this whole combining the I2C codes. Just copy in the functions appropriately, and if you've written them with different function names like this, you can just spit these functions out right into your serial monitor by putting it into your void loop. So I've already uploaded this. Let's see what our output is like. So you can see I'm getting temperature and altitude from the BMP180, and I'm getting our accelerometer and gyroscope values. You can see it's still 70 degrees in the room I'm in. The pressure is about 951 hectopascals, and the height it's showing us is about 145 meters, our elevation here. And you can see as I move the circuit around, you can see the AX/AY, the GX/GY values, all of them are changing. So we've pretty much combined our codes together and we are seeing them work. So this concludes this video. I hope this has been very helpful and you've learned a lot about the I2C protocol. Don't forget to like, share, and subscribe, and please refer to our PDF guides if you have any questions. Thank you.